Uh, Welcome everybody on week 3 of C++ London Uni co-developer skills. Just introduction. My name is Tom Breza. I'm one of the hosts. Today we're actually in force because we have Oliver, we got Tristan who will lead today's class, and we have Justin. So we're in force. Uh, so what do we have today for you? Let's see if that works. First of all, obviously, a massive thank you to our sponsors and hosts. Binary District and Primal Base. We have this wonderful space, thanks to their kindness. Thank you very much. We really appreciate your effort. Without you, this class pretty much wouldn't be possible, at least not in the form like we would like it. So the next part is obviously we'd like to thank all the sponsors, our community sponsors, people who basically decide that what we do is a good quality, and they decide to become our patrons, and they pay every month certain amount of money. We always encourage users who can, if you're basically in a full employment, consider and you like and you enjoy and it brings you benefit, consider paying a couple of pounds, because we spend the money buying the microphones and so on, stickers and so on. That comes basically from the donation, because unfortunately we don't have any kind of sponsorship. The issue number 1 for us, as you saw last week, we didn't have one class because we couldn't find a space. So if you know anybody, do send them into our directions, either to me or to the other guys. And if we have a space like that, where we have a reasonably quiet, with a desk, chairs, internet, big screen, and it's accessible on a regular basis, that's what we need. Yeah? So if you can help, if you know, send them through. It's not just effort of me, Oli, Tristan, and so on. It's basically effort from everybody. We can't always secure the space. We need your help as well. How our classes are being structured. So basically, we have 2 meetings a week. Yes, the first meeting, which is happening on Tuesday, so it's today, we are doing lectures. So one of the very experienced professionals will tell you about certain specific subject. At the end of that, you will be pretty much sure that you understand everything. But trust me, when you get home, or if you sit on some sort of job interview and suddenly you have to do the stuff which was told to you on a class, that might become very difficult. So what we decided to do on Thursdays are workshops. So basically you sit down with experienced developer and you can run your projects. Yes, you can either run the project, learn the stuff which we had today, and so on. It's a fantastic way to accelerate your process of becoming a software developer. So I do honestly advocate not to missing this, because they are really important. Okay, how to sponsor, how to help us. As I said, this is a two-way street. It's not just us, yeah? I mean, we're not doing this, nobody's, we don't have Bill Gates or Mark Zuckerberg, paying us lots of money to run this. We do this because we'd like to help people, yes? It's completely unfunded, at least for now. We're looking for the sponsors. But as I mentioned before, there's a couple of ways how you can help us. Patreon, I just mentioned before. Sponsorship, so basically sponsors. If you know any business that would be interested in, let's say, advertisements sort, or let's say leading some of the classes which might be of use to you as well, let's say about certain product, we are open to basically a chat with these people and see if they would be willing to help us either with a space or some kind of other way. Another one is these guys, they put a really big effort on a day, yes, to prepare the slides and then lead the class. That's pretty much a half a day effort. So as a way of us, me including, yes, it's a good idea to buy these guys a hot meal and a couple of drinks when we go to the pub afterwards. So please do help, yes, because at the moment we got close to 20 people. That's probably £2 per person, yes? But if suddenly everybody disappears and there's 2 people left, then these 2 people, if they want to do it, that costs them like 20 quid. Yeah, so, and if it is the same people every week, that's not very fair on them. But I leave this to your conscience. Another way to support us, but more this is more towards helping you. It helps us in a proxy, but more about helping you. If you have a laptop, you don't know how to set up the environment, let's say, or is it company laptop, you don't want to use it, you can't use it, what you can do, you can purchase from us one of the flash USB memory sticks. It will boot as a Linux operating system, fully equipped with the CLion, all the compilers and so on. Be reasonably easy for you to start and work on it. If you need one of these, we recommend a price for £15. Please do pop in, either talk to me or Ollie. We'll give you one of the sticks, and you can use it. Finally, the more people know about us, the more people we can help, then more it's easier for us to maybe find sponsors or people who will be willing to help us. Yes, these guys, yes, they found about us thanks to the sharing posts. Masabi, another place, they found about us through the meetup. So the input from you actually do make a difference. So if you have a Twitter, Facebook, anything like it, just share stories about us, link about us. Say, I've been here with these guys. They're really great. They help they'll teach you for free. Please do. This way, basically, we're spreading the word. Yes, we don't have a marketing budget. You are our marketing. Yes. So if you want the classes to be successful, please do some work. Obviously, always check our website, cpplondonuni.com, and over there, I try to put the most up-to-date information where the classes are taking place, and obviously whether you have to RSVP on our website, or let's say if we go to the Skills Matters, let's maybe on their website. So it's very important because in some of the buildings, let's say if we go to Bloomberg and so on, they're very strict. We can't just sign in on the day. So please do read the website, because I try to put there quite a lot of effort to make sure that this is working. So finally, I think that's all from me. I stop, talking rubbish, and I'm passing you to somebody who will tell you way more interesting stuff.
I don't know about that. Go Yay. Okay, here we are. Welcome everybody to session 3 of a module we're calling Core Developer Skills. So most of you are familiar faces. You've been to the last couple of these. So who's here for the first time? Anybody? Yes. Welcome, all of you. So I'll say a little bit more about this in a moment, but we're although we're C++ London Uni, in this particular module, we're not actually focusing on C++ itself. We're going over some other skills that will help you as a developer. So I'll talk about that in a moment. Before I really begin, Tom's already said it, but thank you again to Primal Base and to Binary District for letting us have this amazing space. For those who are watching online and can't see, we're on the 32nd floor overlooking the City of London, and it's quite incredible. So we very much appreciate them letting us be here, so thank you to them. The other thing to get out of the way before we really begin is my usual slide on feedback. So we have this Slack channel we encourage everybody to join, for those who haven't already. So if you head to that URL, slack.cpp.al, you can join the CPP Lang Slack, C++ language Slack. We've got our own chat room in there, #CPP London Uni. And we're all in there most of the time. And on our phones when we're not in front of our computers. So that's a great way to talk to everybody and to talk to us and to give us feedback. So we do encourage everybody to join that. Okay, about this module. So, as I was saying a moment ago, this is core developer skills. And unlike our other modules, in this module, we're not teaching you any new C++. We'll be using C++ for some examples, but it's nothing new, nothing we haven't done before. So instead, we're going to be looking at other things that are useful for you as a developer, things that you will use that are not directly, not C++ specific. So the last couple of weeks ago, because we didn't have a class last week, and the week before we had a special guest, so it's now 3 weeks ago, we were looking at GitHub, and the session before that we were looking at Git more generally. So if you missed those, the talks are online, the teaching materials are online, so you can catch up on those pretty easily. Today we're going to be having an introduction to CMake. We'll do a bit more on it next week. Other things we've got planned for this module, we're going to look at using the debugger in various IDEs, how you can step through your program, see what's happening as your program is running. Use it to find bugs in your program, use it to find why things are crashing, that sort of thing. Very useful. We're going to be looking at continuous integration systems. So these are ways of automatically running tests, for example. When your program, every time someone checks into the master branch, that's the way it usually works, it'll kick off some servers somewhere that will compile your program, make sure it all compiles, make sure all your tests run, make sure nothing's broken, and alert you if it does. So we'll go over some of the common ones that are used and how you can set those up for your own projects. And more. There are a few other things we're thinking about doing for this module, but if there's anything specific that you want us to cover and you think would be useful for this module, then please do get in touch with us. You can email us, you can contact us via the website, or via the Slack channel. Say that louder, Tom.
Okay, just a reminder, one of the last classes will be questions, interview questions, and what we need from you, if you have any questions which you would like us to address, yes, I mean these guys, yes, how they deal with the difficult questions or type of software developer type of questions, send us the list of those questions so we have time to prepare this.
So there's two basic ways it goes. If you have questions that you've been asked in the past that you know of and would like to ask us to try and find good answers to, no guarantee of course, then please throw those at us. For those of you who don't necessarily have any questions but would like us to simply guide you, please also go to us with that as well. So whether you're on, there's two sides, right? There's either I have questions, please answer these, come to us with those. And if you're saying, I don't have questions, but I'd like to know what to expect, please also give us that. Give us either direction, and we can build the session off of that, really.
Absolutely. Also, Ollie doesn't know this yet, but I want him to do a session on sanitizers, which is a bit more C++ specific, but still useful, I think, for this module. Okay, so last time, which is now 3 weeks ago, ages ago, I hope you all had a nice Easter break, by the way. Unheard of good weather on a long weekend in Britain. It was fantastic. But anyway, yes, last time we were here, in fact, we looked at GitHub. I'm sure you've all heard of GitHub. Most of you have probably used GitHub. And we looked at creating a repository, uploading project, using Git remotes, submitting issues, forking projects on GitHub, submitting pull requests. As I say, that video is available online on our YouTube channel, so go to youtube.com/cpplondonuni if you missed it. And yes, you can catch up with that. This week we're going to be talking about CMake. So CMake is a common build system that's used for C++ projects. In fact, the most common, I would say. Certainly for open source projects. Almost all of them these days use CMake. So we're going to be looking at, well, we're going to start off with the basics. What is a build system anyway? Why do we want one? What's it good for? We're going to look at the fundamentals of CMake. Creating a build configuration, building a project, and then how you change the options, how you use what are generators. We'll go over what generators are. Today we're going to go over really how you use CMake. So if you have a project from the internet that you've downloaded that uses CMake, you want to know how you get started with that. And then next week we'll go on to talk about actually configuring CMake for your own projects, writing your own config files, editing those, what are targets, how do you set build flags, that sort of thing. So today it's the introduction. Next week we'll go over something that's a bit more complicated. So that's what's on the menu for today. Does that sound good?
Yep.
Rousing. One person was enthused. The rest of you can just look out of the window and admire the view. Okay. So before we talk about CMake specifically, let's talk about build systems in general. What is it? Why do we want one? What does it do? Well, when we write C++, what do? We actually just write a text file, right? And we give it the extension CPP or one of the other commonly used extensions. And it's just a text file. And then we give that text file to a compiler. A compiler reads that source code, parses it, translates it, and gives us out machine code that we can run on our computer. Right? So C++ is a compiled language, doesn't run through an interpreter or anything like that. We give it text, it gives us out a program. So we have a program on a computer called a compiler, we give it source code, and it gives us out an executable. But realistically, any non-trivial program is probably going to have more than one source file. And if we want to, we can actually pass multiple source files to the compiler at once. And what it will do is it will read all those source files, it will work out the function calls between them, and it will spit you out an executable. Yes?
Just worth mentioning that even if you do this, that's just for convenience. They are still processed completely separately.
Yes. Conceptually, you can pass multiple source files. You can invoke GCC or Clang or whatever with multiple source files, and it will give you an executable. And for small projects, we can do this. If we've got 3 or 4 source files, it's not a big deal. We can do this. We can manage it. But as our project grows, as it grows into something a bit more realistic, this becomes problematic. If you've got 20 source files, 50 source files, 100, 1,000, thousands as some big projects have, you don't want to send all of those to the compiler all in one go. Because then it has to recompile your entire millions of lines of source code all at once. This can be very, very slow. So instead what we want to do is to send each file individually to the compiler, one at a time. Well, in parallel if you have multiple cores on your computer, but send each file to the compiler, and it will give you back something called an object file, which is like an intermediate file. It contains all the code for your functions, compiled code, but you can't run an object file. It's a sort of intermediate. And then a second program called the linker takes these object files and links them together into something that your computer can run and understand as a program. So conceptually, oh, too far. That's the one. Conceptually, it looks more like this. We have all our individual source files, 3, you might have 3,000. And we send each one individually to the compiler, which produces a set of object files for us. And then we take all these object files and we pass them to the linker. And the linker is what creates the executable. Now actually in the simplified diagram that I showed you before, where it was just source file compiler executable, it was actually doing this. It was actually doing the linking step. But it's sort of, for convenience, it does it all in, it appears to be all in one go. Really, in the background, it is running the linker, but it's not something you have to worry about. But if we're doing this, what's called separate compilation, then we do actually have to invoke the linker ourselves. So you think, well, this is complicated. Why would you do this? Well, let's say I edit just this first source file at the top. None of the others have changed. Then if I want to regenerate my executable, all I have to do is recompile that one object file and then relink everything. Whereas in the first model, where I was sending all the files to the compiler at the same time, it was having to recompile everything, all my potentially thousands of source files. And so one little change could end up taking a couple of hours to build, if we're talking about something really big, like you're building a web browser or a game or something like that. Even on a smaller scale, it might take a couple of minutes, which is really annoying if you're sitting in front of your laptop, waiting a couple of minutes just for a one-line change, just to see if it worked. But with this separate compilation, it only has to recompile one file and then do the linking. So it's potentially much faster. Oh yes, and real-world programs, again, anything sort of non-trivial, we're going to end up using libraries. That is, other people's code that we want to reuse in our program. And libraries, at least a simplified way of thinking about them, is they're kind of like object files which are made available on your system. They're sort of like object files, but in a special format that the linker can understand. So we pass the libraries to the linker in the linking step. And you will certainly all have used libraries on this course. We use a C++ standard library right from lesson number 1. And we also had this pad left library that we were playing with last time, for those who remember that. So our complicated, where is it? Our complicated diagram has got a little bit more complicated because we want to tell the linker about all our libraries as well. So every time we run the linker, we have to give it, complicated flags to tell it exactly where these libraries live. And this becomes a real headache. Managing the process, managing this process, running the compiler individually for each source file, producing our object files, linking them together with whatever libraries we're using. It can become very tiresome. Repetitive, tiresome work. Distracts from doing actual programming. And what do we do when we have repetitive, tiresome work? We're computer programmers. We automate it. So a build system is something we use that automates this process of compiling, of linking in our libraries, producing our what are called build targets, usually executables or sometimes libraries. And build systems are pretty smart. They can notice when source files have changed, which source files have changed. And when you edit a file, and you press compile or you do it on the command line, it knows which object files it needs to recompile. Right, so it will recompile only what is necessary. So it's pretty smart. And in fact, they're kind of more smart than that even, because C++ and C have this header file inclusion mechanism, which we've gone over in the course before, so you can look back on that if you like. But basically it involves kind of copying and pasting the text of headers into the top of your source files. And build systems, at least build systems that are aimed at C++ and C, they understand this include file mechanism. So they know if you've changed a header, they know that will, in turn, because of the copy and paste mechanism, that will change all these source files which hash include that header. And it will recompile all of those source files. So they understand headers, they understand source files, and they recompile the right things at the right time, so you don't have to think about it. Build systems are sort of the bane of everyone's life, but also a lifesaver because they take care of stuff we don't want to have to take care of, and everybody complains about them, which is a bit unfair, really, because actually what they do is kind of great. There are many, 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 many build systems out there, and a new one sort of springs up every week. You'll have someone declaring everything we've got is rubbish, and I've come up with something that's much better, and almost none of them ever go anywhere. There are some big ones, some popular ones, and the most popular of them all is CMake, or at least for C++. The most popular of them all is CMake. But there are also those things like auto tools and pre-make and scones and lots of others that I've forgotten. But CMake, again, just as we said a couple of weeks ago with Git, well, yes, there are other source code managers out there, but Git's the most popular, so that's the one we'll concentrate on. CMake's the most popular one, so that's what we're going to concentrate on. So any questions about build systems in general, what they are, why we want them? No? Excellent. All right. So yes, CMake's a build system for C++. Well, and C, and Fortran, and if you talk to it right, Python and Swift and loads of other languages I've probably forgotten. If you want to be a bit sort of pedantic about it, you could argue that CMake is technically a meta build system. That is, CMake doesn't actually invoke the compiler itself. What it does is it writes configuration scripts for some other lower level tool. Ninja, GNU Make, MS Build, Xcode, Visual Studio, whatever. That distinction is not very important now. We'll talk about it again towards the end of the session when we talk about generators. But just in case there's anybody being really pedantic going, well, actually, CMake's a meta build system. This is me saying, yeah, I know, we're going to talk about it. So the great thing about CMake is that it's really well supported by the majority of C++ IDEs. So CLion, which is the one we use in this class, it is the build system for CLion, right? CLion can generate a CMake config for you. It can understand CMake configurations from external projects. It can add things to your CMake configuration file. It can manage CMake for you. So CLion's really good. Qt Creator also had support. Recent versions of Visual Studio also have pretty decent direct support for CMake. So if you use CMake for your project, you can now, in the 2018 version, 17 maybe, 17 version, you can actually just open your project directly in Visual Studio and just hit compile and it will do the things.
You can think of CMake as a build system generator.
Yeah.
It's in the same way that C++ generates the machine code that runs. CMake generates the build system for whatever platform you're on. It will work for Mac, it will work for Windows, and it will work for Linux, which is wonderful. It's completely cross-platform, as long as you make sure your code is, of course, also cross-platform.
Yeah, that's worth pointing out, is that CMake, not only is it well supported in IDEs, but also on pretty much any platform you would ever think about developing on. Right, so it is supported on Windows and on Macs and on Linux and any flavor of BSD that you like, or whatever operating system you're using, you can pretty much guarantee CMake will work on it. You can also do, we won't cover it here, but you can do something called cross-compilation, so you can use CMake to generate, to invoke a compiler that builds your program to run on some other system, but that's a bit more than we want to go into today. So yes, many IDEs support CMake, and those that do, it's great because you can just hit the run button or the build button or whatever it is, and it will run all the commands in the background, and your window will pop up, or whatever it is that your program does. It will just happen. But it's also possible, common, I do it most of the time, to run CMake commands on the command line manually. And doing that gives you a much better idea of what CMake's actually doing behind the scenes. So that's what we're going to have a bit of fun doing today. Well, I say fun, hopefully fun. So, as I said, today's going to be about using CMake. Next week, we're going to go on to talk about actually writing your own CMake config files. Yeah.
You can also use CMake with a GUI. It has a nice visual method of using it. If anybody wants to use that, it's pretty much the same as the...
Yeah, there's a CMake GUI for Windows that lets you, as we'll see in a minute, generate a CMake configuration and look at all your config variables and edit them and things. So, like most other build systems, CMake has a configuration file that tells it about your project. What the project name is, what the name of the executable is, or the name of the library, what your source files are, those sorts of things. And in CMake, this file is called cmakelists.txt, and it must have that capitalization. And it lives at the root of your project. That is the top level directory of your project. Yeah?
So it's a good analogy for a build system. It's more like let's say a management system for your project or your source files. You can manipulate them in this CMake list configuration files, and it knows when to compile and not to compile.
Is it a management system for your source code? It's a management system for how to build your project and for actually running the compiler and for, building your executable, building your library. Yes, your targets, as they're called. So we have our project. It has a cmakelists.txt, which contains the information about the project, the information about the source files, all of that sort of thing. We then want to create a build directory. And for our build directory, we specify a particular configuration for our projects. For example, which compiler we want to use, what optimization settings we want to use, any specific options for that might be, we might want to pass to that particular program when we're building it, that sort of thing. And the build directory, it's our output directory, in a sense. It's where our final executable will be written. It's where all the other intermediate files that are generated along the way. So all those object files I was talking about earlier, they will all be put into this build directory, this output directory. And we can have multiple build directories, each with a different separate configuration. We'll talk about that a little more in a second. So, we create a build directory, we specify the configuration options we want, and then we run CMake again and instruct it to actually build the project. So it's a two-stage process, right? First of all, we create our configuration, and then we build the project using that configuration. So if you do this in an IDE, all this is happening behind the scenes for you in the IDE, in C-Line. It's creating the configuration automatically in the background. That's why it takes a little while when you first open a project. You can see the little progress bar at the bottom will tell you what it's doing. It's creating the configuration for you. And when you press the little play icon, it's doing the second step. It's invoking the build. And as we edit files, we can perform the build step again and again. And CMake watches our source files, knows which ones have changed, and recompiles only the things that are necessary in order to regenerate our program. So if you've got 3,000 source files and you don't touch 2,999 of them, those ones won't have to be recompiled. You'll only have to recompile one source file and then relink. So much, much faster, much better. In fact, CMake's even a bit smarter than that, because if you change the CMake lists.txt, that is, you change the configuration file, CMake is smart enough to regenerate the configuration when you tell it to build. So CMake even watches, not all build systems do this actually, but CMake does. It actually watches its own config file and knows when you've altered its config file.
And that comes with a very important caveat, which is that when you reference your source files, you may be tempted to use the features in CMake that let you do regex matching, like wildcard match star.cpp. And you would think in your head that means that whenever you add a new source code file, it's just going to find it. But it's not. Because at the time of generating the build system from the CMake lists, it will check what's in the directory, and anything that wildcard matches will be matched and then written to a file. And then if you add a new source file and build again, it's going to check the CMake lists. Well, the CMake lists didn't change, of course. So it's not going to run the code that checks for any new files. So avoid any pattern where you match on files in the system separately from your CMake list. Just explicitly list files in CMake lists. Never follow that pattern.
Yes, Ollie's absolutely right. We will talk more about this next week when we actually get to writing our own CMake lists files. But yes, in the CMake system, you need to explicitly list, or you should explicitly list what all your source files are. Works much better that way. Other build systems have ways of sort of noticing them automatically. The cost of that is that it doesn't automatically realize when you've edited the config file. So CMake's trade-off, I think, is the good one. So we have CMake list.txt, which, as I say, is the name of the config file used by CMake. That's how you know it's a CMake project. If you see one of these, if you just find something on GitHub and it's got this CMake list.txt, that tells you it's a CMake project. So it's a text file, right? It's got .txt at the end. Well, yes, it's a text file in the same way that a C++ source file is a text file, right? CMake list.txt is a configuration of a file that's written in the CMake language. So it's kind of a source file in its own right, really. I'm not really sure why they decided on the extension .txt. I suspect this was something that was done many, many years ago when CMake was first started. Windows?
Because obviously if you click on it, it just conveniently opens in your preferred text editor, because Windows relies on extensions.
Well, yeah, but you could make that reasoning for any source file, couldn't you? Wouldn't it be handy if Java files opened in Notepad when you double-click them? Why don't we just write them as...
Yes, it could have been .CMake, but that's
Yeah.
something else.
So, even though it's got a txt ending, it's not a plain text file. It's a source file written in the CMake language. And the CMake language is extraordinarily powerful. It's sort of Turing complete in its own right. It's got functions and macros and all these other things. And it can be used to do extremely complicated things. things, to be honest, I have no idea how people write them. You see these gargantuan CMake functions that are extremely clever, way beyond me. I'm not that much of a CMake expert. It's possible to get by on just a few commands. A bit like Git. You can do very, very complicated things, but for the most part, you probably only need half a dozen commands, which is pretty much what I know, so that's good. So as I say, next week, we're going to go into more detail about exactly what a CMake list.txt contains. But if you go and you look at any CMake project, you can just open this in a regular old text editor, and you can have a look at it yourself. You can sort of get an idea of what it's doing if you've got some familiarity with other build systems. It's a lot easier to understand than something like Auto Tools, which is just awful. CMake lists are much easier for the layman to get their head around. So, as I say, for today, we'll assume we've got a ready-made project that's already using CMake, and we want to know how to get started doing this, using this, building this. And it just so happens that we do have a ready-made CMake project that you'll be downloading in a moment. So, as I say, this is a two-stage process. First, we create our configuration, then we build the project. So, the build directory is where what are called the build artifacts will go. These are things like the intermediate object files, the actual executable targets, the library targets, any source files that we generate along the way. CMake has a facility to let you generate things like headers. Anything that is generated as a result of our build process, we call those build artifacts, and they all live in our build directory. And as I mentioned, each build directory, and we can have several of them, has a single build configuration. There are many different options we can pass to CMake to affect what configurations, what options we have. Optimization settings, which compiler we want, LTO, debug information, yes?
Can one configuration file have conflicts to the other one?
No, all of that wasn't picked up. Can these build configurations have conflicts with each other? And the answer is no, unless you've done something very strange. These output directories are completely independent. So that's again, one thing that's worth pointing out with CMake is that all your output, or worth stressing rather, all your output is placed into this build directory. Other build systems, again, Auto Tools is just the example of how to do everything wrong as far as a build system goes. So yeah, Auto Tools lets you build things in place by default. So your object files end up right next to your source files, and it's confusing and horrible. But with CMake, all of your build artifacts, all of the things you have built, all of the things you have generated, they will go in this one directory. It's all nice and clean.
You should, whenever you use CMake, always have it use some empty folder. It won't stop you from doing it in the same directory as your source code, but it's going to trash the directory. Just run CMake in an empty directory, make it use an empty directory for the build. Additionally, though, what I wanted to say was that build configurations are not always relevant. If you use CMake to generate a Visual Studio project, then obviously it doesn't pick a configuration because you do that inside Visual Studio. However, if you use a simple make or something, then of course you must select a configuration. So whether or not there is a configuration depends on what you're generating. The simple stuff, Ninja, Make, etc. Yes. Visual Studio, Xcode, no.
Well, there goes my trying to keep it simple. Yes, if you're using CMake, as we'll talk about in a bit, if you're using CMake with an alternative generator, then some of this doesn't apply. But for the yes, we have these build configurations that specify what options you want. And it's possible, it's common in fact, to have multiple build directories for a single project. Perhaps you want to test your project with many different compilers. You might want to have a debug build for testing and a release build that you test once in a while to make sure nothing funny has happened and that your release build still works, all of that sort of thing. Oh, we get these all at once. Don't know what happened there. So the way we do this, we create a new directory. New, empty, fresh directory, as Ollie said. It is possible to do it in an existing directory. You don't want to do that because CMake's going to chuck a whole load of new files in there. It's going to mess everything up. So create a new, fresh directory, make dir, something like that, however you prefer to do it. You can set this to live absolutely anywhere on your file system. CMake doesn't care. But it's most common to make it a subdirectory of your project. So you download some project off the internet or you create a new one yourself and you create a subdirectory in there, and it's pretty common, pretty standard to call it build. Just that. And it's going to contain, all the things that you've built. But if you have multiple directories, multiple configurations, then you can give them more specific names. You might call them build clang and build GCC, for example, or you see there build clang debug, build GCC release LTO, whatever. You can call these whatever you like. Most commonly, if you're just doing this on the command line, if you're just doing a quick test of something, I just call it build. Most people do. So create our new directory. We cd into that directory. And then we just run CMake and give it the path to the project. The path to the folder containing cmakelists.txt. So if you follow this common pattern of just having it as a subdirectory of your project, you can just run CMake ... So ... in Unix, it means my parent directory, the parent directory from where I am now. So you can just say CMake ... and it will generate a CMake build configuration for you. In fact, what it will do is it will go and generate build scripts for something like Make or Ninja or whatever. But it's going to generate a configuration. And by default, if you give it no other options, it's going to use your system default C and C++ compilers and Fortran compilers and whatever else this particular project might use. And it's going to use the default optimization settings, which is no optimization.
It's literally the debug mode.
Yeah.
It will literally be the debug build.
Yes. So this is our first step. Create a project directory, cd into it, CMake ... Yes?
Does it also mean that it's delivering me the sample table as well for the debugger?
Yes, so by default, if you have no other options, you'll have debug information, yes. Pass -G or whatever it is for the compiler. Create our configuration. Remember, it's a two-step process. We configure and then we build. And then we rebuild and we rebuild and we rebuild until it works. So the way we do this, I hope this is going to, yes, it has. To build things, we just tell CMake, build this, CMake -- build. And that's it. And if you do this, you'll see lines of progressive output. CMake will, in fact, the underlying build system will tell you how far we've got. It'll say 1%, 2%, and you'll wait for ages the first time. And all your output files will be created in this build directory. And CMake will create or instruct the compiler to generate these object files. Then it will invoke the linker. If you've got multiple executables, it will invoke the linker for each executable. It will do all the things. CMake -- build will build your entire project. And as I say, for large projects, the first time you do this, it has to build everything. It's going to take quite a while. But as we edit our files, we can periodically just rerun this CMake -- build. It's going to look at our source files. It's going to notice which ones have changed, which ones we haven't changed. It's going to know which object files it needs to regenerate. It's going to know which executables it needs to relink. It's pretty smart. So generate our configuration, run builds periodically, every so often, when we change things, when we want to see whether things work. And in fact, this is exactly what IDEs do, what CLion does. When you hit the build button, all it's doing is doing CMake -- build. But we're going to do it on the command line. In fact, we're going to do it in just a minute. But first of all, we need to make sure everyone's got CMake. So hopefully most people have got a laptop in front of them.
If you have CLion and it already works, you have embedded CMake.
Yeah.
Never mind. Yeah. Even if you have CLion, grab CMake.
Yep. So.
Don't need homebrew, by the way. You can just grab that from CMake's website as well.
Yeah, it's just a pain.
It's not. You just drag and drop it into applications.
No, it's not in your path unless you reboot.
Shall we do it or shall we not do it?
If you need help, then I'll...
Yeah, so I want everybody to go and install CMake before we go any further. So please go ahead and do this. If you need any help, stick your hand up and myself or Ollie will come around and give you a hand. You can test whether you've got CMake, by the way. Just open the terminal window and just type CMake. And if it gives you an error saying unknown command, well, you haven't got it. And if it says something like no input files, well, then it's installed. The annoying thing is on Windows, and I don't think there's any way around this, you may have to reboot after installing it. I'm very sorry. You can blame Microsoft.
It says uninstall CMake 3.5, 3.4 or lower first.
Well, do you have CMake installed? If you've got an old version, by the way, nothing we're doing requires a new version of CMake. If you've got a one that's a couple of years old, that's absolutely fine.
I'm not going to do it because it'll fuck up CLion. No,
It won't.
it probably will.
It won't. Yeah. So
I've created a directory, created a build folder,
Yep.
and run CMake here.
yep. Okay. So
Yeah, so do I need to add some
let's have a
files?
look at what's.
Okay. It's all right. No.
Okay, so you need to, first of all, you need to have a CMake list.txt. So you need to have a CMake configuration file. So we're going to do this in the next step. You're going to download a project that's already got a CMake list.txt. So yeah, you need to sort of, it's kind of chicken and egg. You need to have a CMake list in order to generate your config, but there's no point writing this config file before you know what you're doing with it. So I had to decide which one to do first. So we're going to do the usage one first, and then next week we'll talk about actually writing the...
CMake to system path.
I would suggest adding it to your
Yes, do add it to the path.
Add CMake to path for all use.
yeah, that's up to you. You obviously use your Yeah, as long as you open a fresh command prompt after, if you're on Windows, as long as you open a fresh command prompt after installing it, it will work.
Oh, that's good. You don't have...
As long as you select the option in the installer to put it in your path. So I would put it in the path for you or for everyone.
Otherwise, CMake will also fake the bash shell and the project.
That's amazing. Yeah, if you've already got CMake installed, then feel free to admire the view for a couple of minutes.
By the way, we're charging £1 per photo.
They should put one of those telescopes up here, you know, at the seaside where you have to put,
Oh, yeah, we
put
can
money.
zoom in.
Yeah.
The QAP80. Can you see the zoom?
I don't know, I'm afraid. There are a couple around, but not one around you. If you move to the end of that row, there's a charger down there. That might be. So if you pop yourself at the end of this row, there's one just between these two desks. Hey. Okay. Well, you don't have to. It's much. You can just go to that cmake.org/download. But Homebrew is actually really, really useful. So I kind of recommend. Okay. Do you have Homebrew installed? Yes. Okay, cool. So we just do brew install CMake. Nice. It's all good.
That's done.
Okay, and now if we just type CMake, it will tell us something like no input files or something like that. Yeah. So.
Anybody having trouble? Right, let's see how far I've got.
Yeah, would be good. Just white, a little bit of milk.
Yeah,
Or white. Sugar. Thanks. Right.
This is really, you've got to sit here, the sound is really good.
There's no way you weigh that much, right? It's creepy.
I'm a black hole.
See the new Crossrail?
You've got to sit in there and say
Just right.
something. It's really weird sound. If you never, it's just sitting there and
What do you
say
mean, like
something.
the acoustics?
Yeah, really weird. Really weird. I bet it creaks with you as well.
But less. Yeah, it's just echoing.
Yeah, it's weird, isn't it?
I'm not trying to care for that.
Parabolic.
Yeah, exactly.
It's good though, isn't it? You spend, I don't know how much work I get.
You're basically just floating.
Sit in that pit.
Do you reckon does it freely rotate on an axis? Or is it
The
actually?
scary thing is the big arm. It actually extends out.
I mean, what I'm concerned about is that if you were to keep, oh no, it's fixed in place. If you keep turning this, right, eventually the chains will lock up,
screw up the chain.
and eventually you would increase your altitude. Before you plug that, just plug it. Will it plug it? It's the same size. Sorry, I thought you were plugging someone else's laptop into a charger. Not that that's a problem necessarily. It's just you should check the voltage first.
Whoa, 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 whoa. Careful.
Put everything off.
Oh
Yeah.
no, if his Mac loses mains power,
Everything dies.
there's no battery on it. It will kill everything.
It's cool, isn't it? I never knew there was a garden on top of that. That's quite neat. Can have your lunch.
Yeah. Yes, how are we getting on?
Everybody has installed CMake, yeah? After you made the laptop start. Yes.
Okay, you all good there, Sard? Okay, good. Okay.
I'm having Windows problems.
Well, we can go on because we've got a bit more typing to do, I'm afraid. I've got an exercise for you. So what I want you to do is to go and download this padleft library that we worked on a couple of weeks ago. This very silly little library. As with all the other things we do in this course, it uses CMake, so it's quite a good example of a really simple CMake project. So you can git clone this onto your machine, as you saw how to do last time we were here. And then I want you to follow the steps that we've outlined. So I want you to create a new build directory, initialize it with the default configuration, so just do CMake ... on CMake -- build to actually do the build step. And then just have a go at editing one of the source files. Doesn't matter what you do, just add a comment or something. Or on CMake -- build again. Sure, it's good. Oh, thank you. Oh, no, great. Hey.
I'm just wondering about the Git. Is it complex? I've got an account and everything.
Okay, well, you don't even need an account. So if you just click on that button, it'll give you a URL. So just copy and paste that. Copy it, rather. Go back to your terminal and do git, type git clone. Space and then paste. Oh, no. You haven't got Git installed.
Okay.
Right. That's all right. We can fix that. So, oh yeah, because this is your first session. You
Yeah.
said. Oh well,
Yeah.
welcome. Yeah, sure. So, yeah, I mean, I'm good with it. So, we'll go to the URL for it. I've just got this memorized. So this is the website for it. So one of these is download for Windows. Hope you don't mind me doing this.
Oh, no problem, no problem.
Nice fast internet here.
Yeah.
Faster than my house. Isn't it? Is that what it does by default on Windows? That's interesting. So yeah, the Yep. Do you know how to use Vim?
Yes, a little bit.
A little bit. Do you know how to exit Vim?
Control X?
No.
Okay.
That's really the question you need to ask. Do you have Visual Studio Code? Well, basically, pick
Yeah,
one.
I've got Visual Studio Code.
Yeah, that one.
Yeah.
Oh, sorry. Yeah, that's this one, I think. This one's okay. Oh, that I was still reading it and I accidentally pressed it.
Okay.
Anyway, it's fine. So. So once this is done, you might just need to close that terminal prompt and reopen it, or it might work actually. I don't know. I use a Mac, as you can see, so I'm not a Windows expert. Sorry. Let's give that one a second.
I didn't install it, or well,
No, that's 2017.
Because
You can also see the star there.
Oh, okay.
Or that's the default we use.
Okay.
So if you
Because
you can
I
use,
got
for example,
C1
Ninja,
and
Ninja install,
Okay, let's try.
or
Okay.
Let's just try. Get rid of that build
the
file.
thing with C-line.
Build directory,
C-line
regenerating it.
yeah.
Does that for you.
And I created it with Academy.
Which will probably
Yep.
be either Ninja or.
It may be that I've done something wrong in the instructions.
C-line or
Yeah.
C-line they're using.
Have I made a mistake in the instructions?
It needs to be dot, doesn't it? CMake dash dash build dot.
Oh, of course it does.
Yeah,
Yeah.
so you set the binary directory.
I don't know what's happening there.
Okay, so anyway, I have
Ninja is probably a good one.
this
So
one.
can you just go to this again?
Not big N.
Okay.
So anybody who gets to the CMake dash dash build step, it's
No,
not
no, no,
just
that's
dash dash
that's
build.
commands, as in
It's
they want to
dot.
see whether
It's
it's
dash
installed.
dash build
Ah,
space.
so you haven't got a C. So you need to. Are you using Fedora?
No,
Everyone?
Debian.
Yeah, cool.
Debian. Okay, so you need to install a C++ compiler. So
So it's not included with this.
no, you need to actually install one on your system. So that's why it's complaining it can't find a C++ compiler. I'm just going to edit this slide very quickly because I have
Yeah, that's the one.
made a mistake, which is rather embarrassing.
Oh, that's cool.
Yeah. So do you happen to know what a G++ package is called on Debian? Be the same as Ubuntu, but I don't know what it is.
Get install G++ should do it.
Yeah. So if you just go back to your terminal window, I'll do.
You can right click
You might be able to do parallel install if you want to make it quicker.
and
Ah.
space in front.
Can't type.
You're not the cursor there. You need to go there via.
Oh, yeah.
You need to type your password.
Yeah, that's the one. It's GC6, but that should be good enough, right?
Oh yeah.
You're not targeting 17, right?
I think so.
Yes. So the command is
Okay. So if we now. Yeah.
Thanks.
Okay. So
you mind if I just put the
Yeah, it's just not
In the build folder.
yeah, it's all just in the build folder. So
So then if you do this,
trying to build.
Did you clone it too? That's just an empty folder.
Oh, yeah, I cloned it to my printers.
so where are we cloning this to?
wherever you like.
I don't know what that is.
I mean,
Save it or.
you'll copy that URL first. Just click that button. That'll put it on your clipboard. So go into your terminal. Okay. So let's make a directory called Lodon. Oh, I can't type. Okay, so we've now got a directory called CPP London Uni. So now I'm going to git clone that URL. And oh, sorry, wrong one. So you can now see that you've got those source files, including CMake list.txt. So now you can follow those instructions on the screen.
Thank you.
Oh no, you're missing them.
It's basically the same as you would be doing what he's doing there. You just skip basically the make do build, cd build, cmake dot stuff.
From the previous.
Yeah, make a build directory then for it.
Well, he just skipped.
Yeah, you've got CMake build debug. That's the one that's generated by CLion.
Yes.
You can just ignore that and create your own build directory.
Yeah, the point of the exercise is not to use obviously CLI and stuff.
We will come back to that later though, Tom.
Yeah, it's fine, because I wasn't sure.
Anyone else need help?
I know this is sound good.
That was a nice coffee, that, Tom. Thank you.
Yeah. Oh, there you go. Right, okay. What's going on? Oh, you want to phone it? So right, just copy it to clipboard.
See, this is why I just throw in there a little command we covered a couple of weeks ago, so that, you know, it brings it back a bit revision.
So if I do CMake, the 2 dots,
Yep.
I got this error.
Okay, so where are you? Type to PWD.
So
Okay, so you're, yeah.
what did I do? Sorry, my mistake. Okay, thank you. Ignore me.
I know this is silly habit, but I can't change.
I'll come around.
CD to Padlet.
I'll come around that way. Easier. Okay.
I can't change. I can't get to the directory. C plus plus. Do I need to do a S space for the backslash? Just change the directory. That's all I want to do.
Stuff, yeah. So now make a
What have we
directory.
got in here?
That's all right.
Whoa, we've got a lot of. So what's this one's called? What's
C
this one
plus
called?
plus course.
Okay. Yeah, the
That one.
space will be throwing it off.
That's interesting.
It's just
And
yeah.
then CD into that.
Oh, sorry.
If you go up and down, you might go.
CD.
Yeah, you can do it in those single quotes, and that'll let you put a space in.
And you can
Oh, okay.
basically
C-
start running commands.
C
Well, you can
plus
see
plus.
you've just done this, so you now hit.
CHV, right. Okay. DIR. Oh dear.
That's all right.
Pad left, wasn't it? Yeah.
Yep.
Oh, okay. I checked it under the table.
Yep. So this is going to create a new subdirectory. So if you now do dir again, now you'll see you've got a fresh directory called build. Third one down. Yep.
What's this docs? That docs is the direction. Dot is the
The parent. Yeah, they're just shortcuts you can use. Be very careful, please. You've got to put space in. No, you've got, oh, no. So you've got to change, so at the moment, you're in the pad left. So you've got a CD, change directory, space build, yeah. Now you're in the build directory. Ah.
Executable, and then you can
Sorry, I'm just trying something.
permission, change mark plus X on the flash. You know the change mark command.
Okay, do you have a Visual Studio command?
No, I don't have Visual Studio installed.
Chmod space plus X
I only have
means
CLion.
mark the file is executable.
Oh, annoying.
Well, without the
So I
space,
cannot do it.
plus X. So just plus X, space, and then the name of the file, of your binary file.
Binary file.
Well, the file X.
Where is your?
To build.
Do you have a compiler installed that you can? Oh, you would have.
I have in the CLion directory somewhere.
So you can basically own a project,
Okay,
I think it's this file.
It's some long.
yeah.
The tab left button.
Well, 1 second. No, just going to help John.
CMake to
Yeah.
generate the file, build it. So that's the CMake dot.
Justin's help. He said if I did it in the
Generates
wind
files
shell,
that can
it
build
still
it,
doesn't
and the next line,
find
which is dash dash
the
build.
SHX. He was
Have you
found
got
it.
Visual Studio installed?
Yes.
And then
Yes.
does it.
If you go, just go to Start.
Try editing the file.
Don't just type in.
Yes.
Downloaded 2 files from Seth, but there's not a retrievable file.
There should be a Visual Studio
Oh.
code somewhere.
Sorry, visuals.
Oh no,
No.
you don't need that. They should be. You should be able to open a shell with the right things set.
Get back.
Oh, okay.
Maybe you can help.
Hallo, wie geht's?
Ganz gut mit dir.
Ist gut, ja.
Command prompt.
Oh,
That's
okay.
come on.
So I came to this point at build here. So this is my current build directory.
Ah,
Just command prompt.
yeah.
You have to find
That is the library, as it's called. So he has 2 targets. So you'll see that there's one target that it links to the static.
Okay, I might have tried this one.
And then the next one is test Padlet. You will find that inside that test folder.
Okay.
That's the unit tests, basically.
That's the one you want. Yes.
I
Okay.
had,
So
I had it.
yeah.
I've been through that before, I think.
yeah. So if you now CD to that directory
So you
again.
can execute. And yeah, so you can execute that one.
CD.
I'm just having trouble
And then do the same thing again.
accessing the file. So I've tried like file.
Vim. Maybe you can just open it in Visual Studio Code if you want to. Oh, you haven't got Vim installed. Just open it in Visual Studio Code.
Okay, no problem.
It doesn't solve it. You need to type in this path and
So yeah, it turns out that yet again, me using a Mac has made things too easy, and this is, some people are finding this is a bit more tricky with the default configuration on Windows. If you have Visual Studio installed, it will probably have installed something it calls the Visual Studio command prompt. So if you run these instructions with that, it'll be able to find the default compiler. Yeah, for Unix systems, for Macs, it knows what the default system compiler is. But unfortunately for Windows, it doesn't, unless you're using this Visual Studio command prompt. So sorry about that. This is why everything's easier if you use Unix, right?
Builders. So for example, add Visual Studio Code. Wait, I'm opening it wrong. No. Visual Studio Code.
Yeah.
Okay.
You can just use Notepad, to be honest. It doesn't really...
Which you don't have because you have Visual Studio. So we copy W1.
And comment in
it's //
And then just set it
hello world or whatever you like. It really doesn't matter. So save that. Oh, no, you've got to save it with the same file name. Yeah. Yep.
just tells you that the build dictionary is being used to generate.
CD build. No, you've got to, so CD to the directory, change directory to the directory named build. So CD. Yeah.
But you try to generate for different generations as well, and therefore it's easy.
It's the last line. So CMake -- build space dot. You'll see it's noticed that pad left.cpp has changed, and it's regenerated that. It's regenerated the library, and it's regenerated the executable. So that's exactly what was supposed to happen. So you're an exemplary student.
Min DW.
What do you want?
Make sure it's going to keep scaling.
Let's see. Let's see, make from a shell.
Because I was trying, hopefully it will detect cl.exe as the default system default compiler, because it doesn't from an. Oh. Yeah.
And after I changed the file, so it didn't compile tests, yeah, because it's already compiled.
Exactly. So it's, you can see it's just building this object file. It's linking the static library, and then it's linking the executable. So it didn't. Building. If you did it up here, it's building lots more files. Yeah. Yep. So that was what I wanted to show you. Is it's just rebuilding that one file that you changed, not everything else.
Why did he pick the Microsoft compiler? You know, in the command CMake dash.
No, it's done everything right.
But no, the line above, the command above.
Yep.
CMake.
Yep.
Dot dot.
Yeah.
No. CMake build.
Yeah, it looks like everything's worked fine.
It's just a no for the same reason that I'm usually
Yep, so if we do it again, you see, and then we can run build as many times as we like.
I thought he would have picked up GCC. He picked up the Microsoft compiler.
Yeah, so because we didn't tell it which compiler we wanted, it just uses the system default. And on Windows, if you've got Visual Studio installed, your default compiler is the Microsoft compiler.
But I thought when we installed GCC, you had set it as no.
Only for CLion, not for. Now we're not using CLion. We're just doing things manually. So, yeah. It's weird seeing helicopters going lower than the shard.
See, I'm wondering which building is the highest. Because is it just a perspective like this? Is the walkie-talkie is as high as this one?
I don't know. Okay, should we move on? I think most people, it's a bit trickier on Windows. So if you're using Windows, yes, sorry. We do have some very nice Linux USB sticks available that you can just plug and play, and all of this will work much more easily. As with everything, you can make it work on Windows, but it's often a bit more work. Yes. Okay, let's move on. Let's talk about Git. Go back to talking about Git. So we create this build directory that has all of our build artifacts, in it. Has our object files, it has our executables, it has our libraries, has any generated files we might have. All lives in our build directory. These build artifacts are not part of our project. Right? They're not some of the source code to our project. They're part of the build. So these things should definitely not be checked into source control. Right? You definitely don't want to be uploading your exe files to GitHub or anything like that. Right? These generated files are not part of the project. They should not be checked into your Git repository. However, if you follow the instructions I've just given, if you follow the most common pattern for using CMake, and we create a build directory that is a subdirectory of our project, Git, by default, is going to see that you've created this new subdirectory. And it's going to say, you've got some stuff in there. Well, Git doesn't know that the build directory is special. To Git, it's just another bunch of files that you perhaps want to make part of your project. So when we run git status, you'll see it there in red. Untracked files, it will say. This is not ideal, because we have all of these untracked files. Git can't tell the difference. It doesn't know that these things shouldn't be checked in, or by default, it doesn't know that these things shouldn't be checked in. And if we have these unchecked files listed, it sort of pollutes our status, if you see what I mean. We've just got to pretend it's not there. And it makes it far too easy to accidentally add a file that we don't want. And it makes it easy to overlook a file that we actually do want. This particularly happens if you go and use some of the Git GUIs, because it's far too easy to, click to include a file that you shouldn't, or vice versa. So what we want to do is to teach Git that our build directory is special, that it contains stuff that should not be part of our repository. And to do that, we create something called an ignore file. That is a list of files that Git should ignore. Now, this isn't CMake specific. This is sort of going back a couple of weeks and talking about Git again. But it ties into what we're doing today. So we want to create this file to instruct Git to say, I want you to ignore everything in this directory, please. And when you do that, Git will just pretend that doesn't exist. And when you run git status, it simply will not be listed. Nothing in your build directory will be listed, which is exactly what you want, because you really, really don't want to accidentally commit your build artifact. It's very embarrassing if you have a public repo, because then you have to go again and have another commit that reverts that, and oh dear, yes. So what you want to do is you want to teach Git to ignore certain files. And the way to do that is to write a special file called .gitignore. So what we do is we create a new text file at the root of our project, and we name it .gitignore, no extension, .gitignore. And notice that it has a dot at the start of the name. So this is a Unix convention that file names with a dot are hidden files, so they don't appear when you do ls, unless you give it some other options. So yes, it needs to be named .gitignore, just like that. And this is a plain text file, and inside it, we write patterns with wildcards. So if you're used to the shell, use question mark for a single, to mean a single letter, star to mean any pattern of non-white space. So we can write specific file names, or we can write generic patterns and tell Git to ignore any file that matches one of those patterns. So, for example, if we want to ignore any directory whose name begins with the letters BUILD, we can add build star into our gitignore file. And that says, ignore anything that's named build followed by 0 or 1, 0 or more characters. So if you follow this convention of naming your build directories build something, then you can add this pattern to your gitignore file, and it will simply pretend those files don't exist. Those folders don't exist from the point of view of Git. And this is also pretty handy for other things that IDEs like to dump into your project directory when you open them into an IDE. So CLion, if you open your project in CLion, it'll create this .idea folder that has all of CMake's XML junk. CLion, sorry. CLion also, by default, creates its own build directories and it names them CMake-build- whatever. Visual Studio Code, if you use that, you notice when you open a project in VS Code, very often it will create a .vs Code folder. Visual Studio does the same thing. It has a .vs, and it also, if you open it as a CMake project, it'll create this CMake settings.json. Again, this is something that's specific to your computer. It's not part of your, these config files are specific to your computer, specific to your IDE. They shouldn't be checked in to source control.
Is there any simple way, like a foolproof way, so every time you create a project, so you
Yes, there is a way to set these things globally in Git, so your specific Git installation will always ignore these patterns. I just cannot remember how to do it off the top of my head, but Ollie probably knows.
Git slash.
Yeah.
Give me a second.
Yeah, it's a Git config setting, but I can't remember what it is.
It's a file inside your Git, your .git folder that's private to you. But generally speaking, you probably want to share these and just put it in a .git ignore that's in the repo itself.
But yeah, so we can teach Git to ignore our build directory. We can also teach it to ignore all this other nonsense that the IDEs put in there that we don't want to become part of our project.
It's .git/info/exclude.
Okay, I'm sure there's a way to do it globally with Git config.
What do you mean globally?
I mean for all Git projects.
But without it being shared.
Yes, but I can't remember what it is. I always do it per project. I just have a standard git ignore file I copy and paste everywhere. So yes, this is really useful, and as I say, something you will end up doing for most of your projects. Whenever I create a new project, I've just got a standard git ignore file that I copy and paste to all my new projects. Actually, if you don't have a .git ignore file, CLion will prompt you to create one, which is rather nice. So, what I want you to do is to go and create a git ignore file for pad left. Which hopefully I didn't put one in there. Pretty sure I didn't. Do it on. I want you to do all of this on the command line. This is core developer skills, and a core developer skill is absolutely using the command line. Being comfortable doing things on the command line. It's why I got you to do all that Git stuff a couple of weeks ago on the command line. It's why I'm getting you to do all of this on the command line.
It is kind of a core developer skill, but at the same time, you can get away without it. It will make yourselves much more valuable if you can.
Yes.
That's why we encourage it.
Yeah, so hopefully this is a bit of a revision from our session on Git a couple of weeks ago. Using these commands, git state, well, we're only using git status here.
Should there be things in the file already?
Is there a git ignore already?
Well, I created that,
Oh, wow.
and that wasn't there. I don't know what that means.
Not git config. You've opened
That's
git config,
why,
yeah.
okay.
Yeah, so there.
Okay, no worries.
Yeah.
Although I don't know if it will work on test. Just do a quick test, not touch anything at all. Yeah, okay, fine. It is boxed.
Okay. All right. So if you cd, so which directory are you in? That's,
Right, so in theory, is this, what was this to kill it?
pad left master.
Kill it,
Right.
so
So if we
reopen
cd dot
That's the visual
g i t
Yeah, that was one I was on.
So you wanted some NGW, didn't you?
Yeah, but I was
Status,
going
no.
to a, whichever
I
one
can't
was on.
type very well like
That's
this.
just a command
Just,
prompt.
yeah, just try it then. Okay, no, I see what you're saying. Try it then. No, just do git,
Oh.
git, no arguments.
Oh, okay.
Yeah, it works.
Okay, right.
How did you clone this from GitHub when you got the zip file? Ah, okay. So what we need to do is to actually do a git clone from GitHub. So if you go to the repository, which is github.com/cpplondonuni/padleft, there'll be a green button on the right-hand side that will say clone or download. Can you? So if we go to,
You just copy the URL. And then
so
use the command line.
that just copies it to the clipboard. So where is it? Command tab, back to there. So it's So it's going to clone that URL. So now we can cd pad left. Now do ls. We can see we've got all the files in there, and if we do git status, it's going to tell us hopefully tell us our working tree is clean, everything's fine. But if we do those steps that we did for the last exercise, so we're going to create a build directory, not make dit, make dir.
How do you make a file? Is it make file? I'm going to make file. Create a new text file.
You could just try touch.
I was just going to try everything on the command line.
No, I know, but what you can use to put text in the file?
Notepad.
Notepad.
Right. Yeah, that's the easiest one.
Cheating. So touch. You touch.
Just type in touch.
Touch, and then the file name you want to. Touch will either update the modified time of the file or create the file.
Okay, so what I've done is I've done the steps from the last exercise.
Thank you. If Windows has it. Windows does
Okay.
not. I mean, just open that. If you can
So
use
now,
it anyway, just open
if we look in the directory, we've got this new build folder in there, and if we do git status,
from the command line.
That's what I thought that was what the object of it.
Notepad's a GUI though, isn't it? Like use,
Well, I don't.
use Vim or
I can use anything. I haven't done it.
It depends.
then we'll see we've got this untracked files. So the new directory is listed as untracked. So we need to create a .gitignore file to tell it to ignore the build directory. So you're now good to go on the exercise.
No, I use.
Yes.
I ran it. I did git add. And I did
You are so good.
Yeah.
Honestly, this is very good for your first ever sessions. Right, so you need to give it a commit message. So you can just say add.gitignore.
wait, after that?
No, this is no, just in here. So this is like a human readable message.
Okay.
It's just, if anyone's looking at the history of this repository, they know what changes you did. So just save this, and then close that window. Oh, sorry, that tab.
Tab.
Yeah, tab should be enough. And then if you go back to your terminal, you'll see it's, right, it's in there. Yep, so it's done. It's 2 files changed, 2 insertions, 1 deletion. So if we now run git status, doesn't have tab completion. Git status. You say our branch is 1 commit ahead because we've added 3, but nothing to commit. Working tree clean. So it's not listing build. It's not listing .gitignore.
Gotcha.
All good. So now, if you want to, well, you could try doing this last step, but you actually haven't got any of these other useless directories I was talking about. So you're all done. Awesome.
No. You don't know. Each line is a file. So you don't.
there's no longer listed. And you see
So what's optimized, what's not optimized. And you can tell CMake build, CMake build release, or CMake build whatever. So you need to tell it what to
Or
build.
just commit.
You don't have to. No, you don't.
You might just rename it.
Folder,
Rename it.
yeah, in which case, in this case, it would
So-
be dot for the local.
So
You're all done.
Yes.
Just type git status.
Oh, sorry, I'm helping in.
All good. Working tree clean. Everything's good. Awesome.
it's quite fun.
No. It's all good.
In this file, add a line to ignore the build site.
Is that the right
Okay, so where's your terminal window?
Let's type in a file name.
Okay. So have you created .getignore?
Try again.
Oh, thank you. Yeah. So have you got a text editor open with this? Is it that one? Oh, that's not it.
Oh, that
Sorry.
is open then. No, I haven't. No, I haven't.
Okay, so let's try just opening. Where is it? Let's try opening .getignore in here. Oh, you know where it is, I guess.
It's like the scale, the layer between like adding the next layer after
It's a
adding.
mess. No, I can't book it.
I do that. I've got to just there it is. Pad left. No,
That's
no.
okay, we can have some command line.
So when you just click that, what happens?
Open in the MinGW terminal.
So
or whatever.
yeah. So it's got to be pad left, not pad left master.
Go to start menu, and then find MinGW.
That's the one.
At the moment, no one
So you can
So,
just no. So just click open, and it should will flash, and then you can see this .getignore here. So just click on that, and now it's an empty file. So you just want to just type in build followed by a slash. So this is going to ignore a directory named build. So save that. Go back to the terminal and type git status.
C, isn't it? In your no, just hit tab. Just hit tab. No, do a C.
Not quite.
yeah, that's where you can't spell. Type too fast.
Don't worry, I do that all the time. Okay, so you notice it's no longer listing the build directory. So before, last time we did this, it was saying untracked files build, and now it knows the build directory special. It's ignoring the build directory. But it's saying, hang on, we do now have an untracked file called gitignore, because you've added a new file.
So it's instead of looking at my build file, it's looking at what's getting ignored.
Well, git status lists all the files that haven't yet been added to the repository. Yeah. So until we told it to ignore the build directory, it listed that. And now we've created an ignore file, and the ignore file says ignore this build directory. Right? So it's obeying that. But the ignore file itself is a new file, right? So it's listing the new file.
So the build directory point things that you don't want to do.
Sorry? Yeah, things that it should ignore. Yeah.
So if I just
No. The git ignore file is for things that Git should pay no attention to whatsoever. Things that Git should ignore.
So when we don't have git ignore, what happens to the build? It's saying untracked file build.
Yeah.
What does that say?
It's saying, well, hang on, I can see all of these files are in this directory, but you haven't yet added them to the repository. It's alerting you that there are untracked files, right? But for exactly, so we want to teach Git to ignore those, and that's the purpose of a git ignore file.
So,
right. Anyway,
so what we're saying, basically, we're saying to the
where were we? Right. Create new
what's
check.
that whole system to like the CMake build thing? Like when we do this, we
Yeah.
don't put the build file.
No, we're not talking about CMake now. We've sort of put CMake to one side for a second. We're talking about Git again now. And the purpose of this is to tell our source control system these files are not part of our project. Everything within the build directory, that's specific to my machine. It's not part of the project. Please ignore it. Exactly. Won't have things specific to your machine in it. Yep. But having done that, we've created this new file called .gitignore. And so what this is saying is, hang on, we've got a new file called .gitignore. So what we need to do is to commit this file to our repository. So we need to do the git add and git commit steps that we did a couple of weeks ago.
I might create another page.
Shattered.
And then just do it on
No, it's all fine, it's all fine. Right, so,
He's an IDE and messing around with it.
I use
no.
That's terrible. That's
Basically, I've got to commit this.
You've got to commit the .gitignore file to the repository, yes. Well, it actually tells you what you need to do. So do git add file. So git add space .gitignore. Or you can
Just do a new command, maybe needs to refresh.
enter. Now do git status again. Or you can just press up, key a couple of times. Oh, no, you can't. Sorry.
Oh, it's a bit better.
Okay. So it's saying we've now added this to the set of changes for our next commit. So if we now do, we can now do git
Screen text.
git commit -m.
It's a bad experience.
It is a bad experience. Anyway, okay, so right.
with other companies.
So what does that say?
Companies have agreed basically.
Okay, so git.
What does the M
okay,
say?
So the M says, so you remember when we create a commit, we need to give a message saying what changed in this commit. So -m is just like a shortcut to say this is the commit message.
So we added git.gitignore.
Oh, God. Oh, don't worry. So now, if you do git status, button,
Thank you.
we'll see
No contract.
nothing to commit, working tree clean, everything's good, it all works. And we can do git log,
That's good. I don't mind.
Mom, no hands.
yeah,
And I get to learn to use Vim as
git
well.
log, and now you've,
So you need
This
to
is a lot
enter
of things we've
insert
committed.
mode.
yep, so I did that one, and then Tom added a commit, and this is the point at which you downloaded, and then you've added this new commit yourself,
Okay.
right?
Amazon Web Services.
Yeah, don't worry about that bit too much.
Saving commit, so you do colon to start into the
Yeah.
command, you use the right command, follow by the quit command, it's fine.
Maybe I'm not going to get that. It sounds like a cleaning fluid. It's not a text editor.
Sounds like a drink you give to kids.
Yeah.
Once you get used to it, once you get used to it, you know how to move around with it. It's extremely efficient. It's got shortcuts for doing anything. Like I want to copy a chunk of text, like by line, you just go like yank line, paste it in. You can manipulate text really fast with it once you use it.
Yeah.
Okay.
But when you're not used to it, it's usually
Yes.
And the best bit is you could ignore 30 years of muscle memory that says Control-C is copy and Control-V is paste.
yes, it's just why.
Because,
Yank, yank, paste.
you know, why would you want to use industry standard shortcuts? Well, yes, but, you know. Are you struggling with this?
No, it's done, but I can't read the commands.
Oh yeah, he's using PowerShell terminal. He's recolored it. It's basically unreadable.
Ollie just coloured everything to black.
Well, we tried it. It helped a bit.
None more black.
It helped
All right.
with the windows.
Okay, so that bit, those last couple of slides, that little exercise, wasn't really CMake specific. It was going back a couple of lessons and talking about Git again. But when we did that, I didn't cover gitignore files, and they're pretty useful. So I thought this was a good opportunity to tell you about gitignore files. In particular, it's very useful to ignore build directories so that you don't end up accidentally committing things that are specific to your machine, specific to your build config. Yeah.
In general, then you push this gitignore file to your.
Yes. Yeah. So most projects, if you go and just browse on GitHub, most projects will have a .gitignore file that ignores. Usually they'd have a big long list of file types or patterns to ignore. I didn't mention actually you can put comments in the .gitignore file as well. Anything that's any line with the first character as a hash is a comment in a .gitignore file. So you can do that if you like. So let's go back to talking about something specific to CMake. So about build types. I've mentioned this already. We talked about, I sort of dropped it in, talking about debug builds, talking about release builds. What are they? What do they mean? Well, CMake understands 4 build types, build levels, you might call them, for projects. And these are a debug build. So this is what you get by default if you don't ask it for anything different. And in a debug build, you get no optimization. It invokes the compiler with -0, for those who know what that means. So you get no optimization. You get all the debug information. It's generated, so you get large, slow executables, which is usually not what we want. But actually, it means that it's much easier to debug your programs. It means that, as we'll go on to talk about in a week or two, you can look at these files, you can watch what happens as your program runs by using a debugger. So by the default configuration is what it calls debug. CMake also has what it calls a release configuration. And for release builds, optimization is enabled. I'm pretty sure it's 02. I didn't check. From memory, it's 02. It might be 03, but I think it's 02. It is 03. Oh, well, there you are. It's actually really aggressive optimization, 03. It disables asserts. It defines a symbol ndebug. And it doesn't generate any debug information. This means that you cannot look at your release binaries in a debugger. So debug is what you want when you're just working on the programs yourself. When you're just doing your, edit, build, test, debug cycle, you want the debug build. When you actually want to build your program to give to somebody else so that for your end users, or perhaps if you're building somebody else's project that you're not planning on editing yourself, but you just want to run their program, then you want to create a release configuration. That's going to be much, much faster than the debug build. Things can literally be hundreds or thousands of times faster with optimization enabled. It's incredible, actually, sometimes. There's also something called rel with deb info, or release with debug info, except it's spelt this way. Rel with deb info. So this does the same things that the release build target does, or build type does, except that it still generates debug information. So in principle, this means that you can step through your executables, your whatever you've got, you can step through them in a debugger, in principle. However, because it enables all the optimizations, it turns out that this is still not actually a very easy to debugging experience.
So that's completely true. There is a caveat, which is this is actually generally a preferred option because what you will usually do afterwards is package your application in some way. So an RPM, whatever. And that will take the, yes, rather large binary, but it will separate the debug information out. So it will strip it away into a separate file, or set of files. And then you have what's called your debug info packaging, which is a separate package from the actual application. So this is something that we do. And essentially we always build rel of deb info because we have two RPMs. We have the RPM that is just the application itself, which is quite small after it's been built. And the debug info is separated away. But in the event that something goes wrong, there's a crash, whatever, we can then just deploy that debug info package on the servers and then get a stack trace.
Yeah, so this is something that's, I think, well, it's not actually Linux specific, but in your case, it's Linux specific. You can actually, even after you've created something that's rel with deb info, you can still separate the debug symbols from the actual release build. It's a bit more complicated. Well, it's quite a complicated thing to do, really. So yes, and it's actually still quite hard to step through it with a debugger because you're going to try and step into functions that have just been optimized out. And, but it is very useful because you can get stack traces when things crash and things like that.
Yes, it's not half as complicated as having a crash with a release build and you don't have any debug.
Well, yeah.
And you're stuck.
There's one final one, which is called min size rel, or minimum sized or minimally sized release. So what this does is it performs some optimizations, not as many as 03 or not as many as release, but it performs optimizations aiming to make the resulting binary as small as possible. That is, in terms of the number of bytes it occupies. So compilers have a special mode for doing this. It's -OS for GCC and for Clang. And the min size rel basically instructs the compiler to use its OS mode. This is something you want to do if you're compiling programs for an embedded system that's only got a few kilobytes of RAM or something, and the size of your generated executable really matters. In general, if you're doing something on your laptop, this will make no difference whatsoever. Right? Release is what you want. There are some hypothetical cases, pathological cases, where people claim that OS will actually generate faster code than 03. I don't believe them, and if they do, then that's a bug in the compiler as far as I'm concerned.
No, they're usually wrong because they're targeting a generic architecture. Generally speaking, if you specifically target whatever CPU it's going to run on, then -03 will be faster than -OS. It's only because you haven't told the compiler what it's actually going to run on, so it has to just assume a generic, has to support all of the 64-bit processors or whatever. Also, to just round this off, all of what you see in front of you on the slides are convenient defaults that will set a bunch of flags and whatever for you. You are quite free to ignore all of what's here and manually set whatever you tell CMake, no, don't care about any of this, set this, and customize it as you see fit.
Yeah, absolutely. These are the built-in levels that CMake knows about. As Ollie says, you can take these and you can customize any of the individual flags it passes to the compiler. I believe you can actually there are ways of creating your own named build levels, although I've never delved into CMake quite enough to do that. But these are the built-in ones. For my purposes, for I guess the purposes of everybody here except Ollie who does funny things, generally the first two are going to be the useful ones. Right? Debug is what you use for your everyday compile, test, debug cycle. That's what you're going to be doing 90% of the time. Release says, make this code as fast as possible, and I don't care if it's hard to debug or impossible to debug. Release says, I'm finished, now make it fast. Enable all optimizations if you can, please. And yeah, the other two are for special cases that we're not going to worry about too much. So those are what the build levels are, but how do we tell CMake to use them? Well, when we, Ollie's going to correct me with the generators again, but when we create our build configuration, we need to tell CMake, I want you to create a configuration using this build level, please. So we need to pass it that's on 2 lines and it shouldn't be. We pass it the flag, we say -d, define is what it's for, -d CMake underscore build underscore type equals level. One of those things that was on the previous screen. Debug, release, rel with deb info, min size rel. That there should not be this is formatted badly, I'm sorry. There should not be a space between no new line, no space between the minus sign and the D. Let me just see if I can very quickly edit that. Sorry about that. Set enough spaces, it'll work, right? Yeah. So we say -d CMake build type equals whatever.
Is there a space between D and C?
No.
You can put one in it.
Yeah, it'll work if you do, but so for example, we'd say this: CMake dot dot -d CMake build type equals release. With a capital R, it will say, this will tell CMake, I want you to generate me a configuration that's going to call the compiler with the optimization settings enabled. All optimization settings. At least when you're using one of the standard, the simple generators. If you're using one of the generators, and we'll talk about what generators are in just a couple of minutes, but if you're using one of the generators that generates a project file for an IDE, it works a little bit differently. But for the ones that actually generate a build system directly, this is going to generate a build config, a release build config.
Just a bit of trivia as well, since Tom mentioned it. CMake comes with a packaging tool as well, CPack, so you can generate, RPMs or installers and what have you. Unfortunately, for whatever reason, it obviously takes the same -d arguments that CMake does, except when you use CPack, you must put a space after the -d. Whereas in CMake, obviously, you don't have to, but you can. So if you ever do use CPack, be aware of that.
Okay, I must confess, I've never used CPack, but yes, it's useful for generating. Does it generate frameworks on macOS as well if you've got a library?
Installers, like
Yeah.
RPMs, third party.
Yeah.
Well, you mentioned about different levels, O2 and O3. As I understand, O3 is the fastest one. Yes.
Yes, should be, yes.
How do you use this?
Okay, so
O2 is default.
no, in fact, I was incorrect about that. Apparently, release builds do use O3.
Oh, well.
Yeah. So this example, -d CMake build type, is just one particular flag we can tell CMake about. There are lots and lots and lots of others. Perhaps one of the most useful ones is -d CMake underscore CXX underscore compiler. And if you do this and you do equals and you give it the path to a compiler on your system, say, I don't know, /op/gcc/g++ or whatever, it's going to use that as the C++ compiler for this particular configuration. So this is really, really useful if you've got multiple compilers on your system, if you've got Clang and you've got GCC, and maybe you've got a couple of older versions as well installed in funny directories. You can tell CMake, okay, I want you to generate a configuration, and I want you to use this. I want you to use GCC 6 because I want to make sure that my project builds with GCC 6 or whatever. So this is a really, really useful one. There's a corresponding CMake underscore C compiler that you can probably guess what that does.
So would you make multiple compiled versions then run them as a comparison?
Not necessarily as a comparison, but let's say you're writing a library that you want other C++ programmers to be able to use. Right? If your library only works with Clang, that's not very useful.
Oh, I was under the impression that once it's compiled, it will work with every other.
Alas, not, no.
Okay, I just assumed that was a mistake.
No, because, okay, so this is an open source thing. So you're not giving people the compiled files anyway. You're just giving them the source code and letting them compile it themselves. But perhaps you've written your C++ in such a way that only Clang understands it because you've done some extension that only Clang does. So you want to go and you want to test and make sure that your library works with GCC as well. And then if you're using Windows, you probably want to make sure it works with MSVC. So this is a way you can have multiple configs that each target a different compiler. This is not universally true, but very often it's just the easiest way of doing things. Most often, once you have generated a build config, it's not always easy to get CMake to persuade it to use different flags once you've created your build directory. Again, this isn't universally true, but what I find myself doing most often is if I want to change a build flag, I just delete the build directory and create a new one. Most of the time, that's going to be easiest, rather than fighting CMake and it telling you to delete your CMake cache and loads of other things. Just blow away the build directory, create a new one. Simpler and easier. So that's, I guess, a bit of advice rather than a hard and fast rule. You can persuade it to notice new flags. You can run CMake -- CMake ... whatever to regenerate a project config. 90% of the time, I find it easier just get rid of that build directory, create a new one. So there we go. How many build levels does CMake have? 4, which are debug, release, rel with deb info, and the last one, the smallest one, min size rel. Yeah. Which one should you use normally? Debug. And which one should you use when you want it to go really fast? Release. Yeah, all right. Don't even have to write a test for this module. You've all got it already. Okay, well, the other thing is, it's worth noting that these are, at least on Unix systems, these are case sensitive. So you need to type release with a capital R like that. The other thing worth saying is if you don't specify, you're going to get the default config, which is the same as debug. So by default, if you don't specify anything, you're going to get no optimization, and you're going to get full debug info, which is usually what you want.
So you have to be careful when you're debugging something with your timing or something. When you're programming, if you say wait for so many cycles, you have to do it within a clock.
This is
Otherwise, you could zip through your program.
well, we're not getting into this is not CMake specific, but generally you'd if you need to put a pause in there for whatever reason, not always a great thing to do, but let's say I don't know, you're writing a game and you want to wait for the next vertical refresh. You wouldn't just say, you'd use some specific way that's going to work the same whether you've got a debug build or a release build. Okay, so we've got 4 build types. We used -d CMake build type. Let's finally talk about these things that I've been hinting about all night. We've got 5 minutes, which will be just about the right amount of time. So I mentioned this right at the beginning, almost 2 hours ago. CMake's technically what we might call a meta build system. So that means that CMake actually relies on some other lower level tool. And it's this lower level tool that's actually invoking the compiler, invoking the linker. It's not CMake itself, it's this other lower level thing. So CMake generates scripts generally, or configuration files for these other tools. And when we run CMake -- build, what that is actually doing is invoking the lower level tool, which is in turn invoking the compiler and the linker and everything. Right? So CMake -- build is kind of a shortcut to say run make or run ninja or run ms build or whatever it is. So it turns out I've just learned this isn't strictly true on Windows. It generates, I think, NMake files on Windows by default. But certainly on Macs and on Linux, CMake will generate Unix make files. So if you've never come across Unix make files, lucky you. No, some people swear by them. Other people swear at them. I'm the one of the people who swears at them. But yes, make files are, I don't know, 40 years old or something, way of writing a recipe for how to build your software. Not very nice to work with. CMake will generate make files and then invoke the Unix command make, which reads the make file, executes the steps, does all those things. CMake generates a make file, calls make, does it all so you don't have to worry about it. But this is not the only generator available. So you can tell CMake to create a project file for Visual Studio. You can tell CMake, if you're using a Mac, you can tell CMake to generate a project file for Xcode. You can tell it to generate a config file for Sublime Text if you use that, or Notepad++, or it's got quite a few of them these days. I believe so. But it's worth mentioning that whilst it does have this option of generating Visual Studio code, recent versions of Visual Studio, the IDE, as I've mentioned already, they can handle CMake directly, and that's generally better. Going to be a much more, much friendlier experience. So which particular generators are available depends on what operating system you're using. But if you run CMake --help, at the bottom, it'll print out a load of text with all the different options, but right at the bottom, it'll tell you which generators are available. And it will, I believe it has a... Is that so? I actually got this off the CMake website because I wanted to know how to do it, and they said do this. So there you are. They don't know their own tool. Justin knows, but apparently you can type CMake space dash capital G and no other options, and it will list the generators for you.
Because it's expecting one, it's like, you didn't provide one, but here's what you can provide.
So these are, yes, you can use a variety of generators. By default, it's going to write make files, Unix make files, or something very similar on Windows. There are a few other generators. In particular, there is a generator for a low-level build system that's called Ninja. And I mention this because Ninja is particularly useful. In fact, Ninja is great. Because Ninja does the same thing as more or less the same thing as the venerable, old-fashioned 70-year-old make, Unix make, except it's often much faster. Because Ninja does things like automatically parallelizing your build. So if you're sitting there on a computer with 8 cores, it'll go and it'll run 8 versions of the compiler, it'll compile 8 files in parallel and things like that. And it's much quicker at working out dependencies between your targets and things like that. So Ninja is great. I highly recommend it over the default generator. And the way we tell CMake to use the Ninja generator is by saying -g Ninja when we create our build config. So when we do CMake CMake ... say -g Ninja, and that will tell it to use Ninja as its underlying build tool. And Ninja is really fast.
There is one caveat, which is that Ninja, if you use a makefile for a small project and you explicitly pass however many cores you have, the same as Ninja would have done, there's probably going to be really nothing in it unless you have a large project. If it's a large project, it starts to scale. The downside of Ninja as well is that the output is not as nice. You get much nicer progress output from a makefile from CMake than you do from Ninja.
Okay, so we got 1 vote for Ninja and 1 vote for Makefiles.
Not against it. You need to have a project big enough to justify it.
Yeah.
If it's like
If you go and you try and build something like WebKit that you've Git cloned and you want to build it, Ninja is going to be much faster than using the default build system. So I, as just out of habit, I tend to use Ninja whenever I'm manually building something. So yes, once we've created our configuration and told it we want to use the Ninja generator, then when we run CMake --build, or in fact CMake --build dot, which I've consistently forgotten, then it's going to invoke Ninja. You'll notice on the command line the output is slightly different, as Ollie mentioned. But Ninja's great. That's why I'm telling you about it. So it's not installed by default. If you want it, it works for Windows. You can go to ninja-build.org. It's a fairly simplistic website, but there is a download link on there. For Mac, if you're using Homebrew, you can just do brew install Ninja. And Linux, as always, you can just get these from your system package manager. apt-get install Ninja build for Debian-based systems or whatever the equivalent is for your distro. I'm sure Ninja will be on there. So there we are. That is the end of the session, which is great because it's 9 o'clock and it's time to wrap up. So I'll leave you with this little homework exercise. Whoa, I don't quite know what's happened with that. Something fun is going on. Yes, how strange. Because it doesn't show up on this screen. But anyway, so have a go at generating a release configuration of pad left using Ninja, if you fancy it. Perhaps just generate a release configuration using the default generator first, and then try it using Ninja. Might be a little more tricky on Windows than on Unix, but then everything is. You should be able to download a binary for Windows. And then there's maybe a little challenge. Look up how to use CMake. If you're using G++, GCC, or Clang, it has support for sanitizers, which Ollie's going to tell you about in a couple of weeks. So can you work out how to create a CMake configuration which runs one of the sanitizers, for example, ASAN? And as a hint, one of the things you might want to look at is this CMake_CXX_flags configuration variable. So it's 9 o'clock. I'll leave you with that. That is it from me. Thank you, everyone, for coming. Thank you, people online, for listening. If there's anybody left, we are, as always, going to go for a refreshment afterwards. Everybody's more than welcome to join. But that's it. Thank you, and I hope to see you next week.